everyone, welcome to the channel Unknown Physics. So, today we are going to continue with the topic Mechanical Properties of Solids. I have done few videos on this topic. If you have not watched, I am giving the link in the description box. Please do watch and continue for a better understanding. So, in my last video, I have discussed about stress and its types, and I have left with a question for you guys. And the question is, find the SI unit and dimensional formula of volumetric strain. And the answer is Pascal in SI unit. And the dimensional formula is m L power minus 1 T power minus 2. So let's get into today's topic. Today we are going to see about strain and its types. Strain measures how an object is stretched or deformed when a force is applied. Strain deals with the fractional change in the size of the object. In other words, strain measures the degree of deformation. For example, in one dimension, consider a rod of length L. When it stretches to a new length, let it be del L. So then the strain is given by change in dimension by original dimension. So it will be delta L by L. And strain is a dimensionless quantity, so it has no units. And strain can be classified into three types: longitudinal strain, shearing strain, and volume strain. Let us see what it is. First is longitudinal strain. When a rod of length L is pulled by equal and opposite forces, the longitudinal strain is defined as the ratio of change in length of a body to the original length. So longitudinal strain is equal to change in length by original length, that is delta L by L. Longitudinal strain can be classified into two types: tensile strain and compressive strain. So what is a tensile strain? If the length is increased from its natural length, then it is known as tensile strain. Whereas compressive strain is, if the length is decreased from its original length, then it is known as compressive strain. Next is shearing strain. So consider a cuboid as shown in the figure. Let us assume that the body remains in translational and rotational equilibrium. Let us apply the tangential force F as indicated in the figure, such that the cuboid deforms as shown in the figure. Here, hence the shearing strain is defined as the ratio of relative displacement of any layer to its perpendicular distance from its fixed layer. So here your delta x is the relative displacement layer and the distance between the layer is length L, right? So when you take tan theta for this, it will be equal to delta x by L. So it is tan theta by small angle approximation. You can approximate it to theta. Here I have represented it as phi. So shearing strain or shear is equal to delta x by L, that is equal to phi, which is known as angle of shear. So this is due to the change in the shape of the body. And one more thing, shearing strain is equal to 2 times the longitudinal strain. Okay.